All right, guys, I hope you have your notes out. We are going to do a pair deck today, so if you guys could go to joinpd.com and then type in this class code, Stoic Muffins form confused avocados. You don't actually have to type out the words, but the letters help you get into this. And what this is going to do is it's going to project my PowerPoint slide onto your computer, which allows you guys some freedom for taking notes. I can't open this up to student paced and let you work backwards or forwards, depending on how you guys are doing. So today's notes are going to be over functions, and the things that you need to know are located right here. So I'll give you a moment to write those down, and then we'll talk about what each of these means. Just real quick, I'm going to cut some of you guys off. Have any of you guys, let's see, have you used Pear Deck before? Look on your screens and just give me an answer. Have you guys used Pear Deck before? So it looks like 2 of you guys have and 2 of you guys haven't. All right, that's some of the feedback that I wanted. So it looks like most of you guys are finishing up. Just going through what some of these words mean. You can take a look at the example that I have over here on the left. Each set is represented by this capital letter. So we have set A and set B. The elements are the items inside of the sets. And these could be letters, numbers, words. They could be anything that you want. For these basic examples, we're just going to use letters and numbers. Now, bullet point number 1 says each element in A must be matched with an element in B. So these guys are going to pair with certain things in the other set. Every element in A has to have a pair with B. So if I erase the line from 2 to lowercase b, this is no longer a function because 2 doesn't have a matching pair on the right side. Though some elements in set B may not be matched with anything in set A. So for example, if I add that line back, this is still a function even though C doesn't have a partner. And that is okay because of option number 2 there. Number 3, 2 or more elements in A must or may be matched with the same element in B. So I could keep this a function and send the 2 over to the A, and it is still a function. 2 elements in A are matched with the same element in B. The kicker that you get is if you take an element in A and it goes to 2 different elements in B, it's no longer a function. Now, that may seem kind of confusing, especially for some of you guys that are new to this class, but I want you to think about it back in terms of Algebra 1. If we take a graph, which is a visual way of representing these functions, looking at the x-axis and the y-axis, if I have an ordered pair at 1, 2, that is your comparison for set A and B. The x coordinate is the A, the y coordinate is the B. So you have a partnership there. If I had another point at 1, 4, there is now the same element in set A pairing with two different elements in set B. So you have the same x, but you have two different y values. And you might remember that this graph is not a function because it fails the vertical line test. This vertical line touches that not twice. So if you have an element in set A that repeats twice, then it's not a function. So we're going to quiz you guys on some here. So take a look at this example 1 real quick. And in your notebook, I want you guys to make a justification on whether this is or is not a function. So think about it. When I ask the question on Pear Deck, this image is going to disappear, but kind of get your mental answer here. Is this a function, yes or no? So go ahead and give me your responses on the computer. Is this a function, yes or no? And it looks like 3 of the 4 of you guys have answered. And everybody is correct. This is a function. All right, here's the next example right here. Same thing. Is this a function? Yes or no? All right, think about your answer. We're going to lock it in. Yes or no? Is this a function? And you guys are correct. I want you to take this one a step further. So look at this guy right here. And I want you guys to give me a written explanation for why this is not a function. So let's try and get some math vocabulary in our response. Go ahead and type your answer in the computer. And just in case you need to see it one more time, I'm going to kick you guys out of your responses here real quick. Here was the original image. So if you want to go back to your response, you are answering the question why this is not a function. Does anybody need to see the function one more time, or are we good? All right, give me a thumbs up or a thumbs down if you're ready for me to share your answer with the rest of the class. Give me a thumbs up or a thumbs down if you want me to share it. Okay, I'll give you guys just a little bit more time. I remember having you in the USC there, Tobin. Very descriptive answers. I'm going to freeze real quick and see what some of you guys have come up with. So here's what some of your classmates have said. This is not a function because an element of A matches with two different elements of B. I like that student number 2 was even more specific. They said, no, because the input of 4 had two different outputs. So that's a solid explanation. 4 from the A side, which is the domain, is paired with two values from B side. Breaks rule number 4. Nice, I like it, guys. All right. Take a look at this XY table here. You have your inputs, which is set A, your outputs, which is set B. You're trying to determine if this is a function. Okay, yes or no, is this a function? Once again, you guys are good. I want you guys to take a little bit different approach to the question here. What would you need to change in the output so that this was a function? How could we make it a function by changing the output? So looking back at the image here, what could you change so that it is a function?
If you only change the output.
If you only change the output, so looking back at this, if you had to change something in the bottom, what would you change to make it a function? You guys have enough time to put in your responses? Okay. Here is what one of your classmates said. So, does somebody want to share their explanation for how to do it? Tobin, which one is yours?
I just said change the outputs to make the function incorrect to all the same number.
Okay. Any other responses? Megan?
I said you could leave out the output of 2 and 4, or you could leave out -2 and -4, and then 0 and 1 would only be matched with one element.
Nice. Colin, you want to share yours?
Yeah, I said basically as long as 0 and 1 always have the same output, it's a function. So you either have to change the first two where they're negative to positive, or the last two where it's positive to a negative, but they can't change.
Okay, so you could change these to a -2 and that to a -4, and then they'd have the same, and they'd be a function. Cool. I like it. All right, so to finish up, what I want you guys to do is put your notes beneath your desk. So we're gonna go no notes on this question. In your own words, what do you think are the key characteristics of defining a function? So what are the key characteristics of a function?